There we go. Okay, so in Unit 1, we were learning about expressions. And expressions are just math problems or something where it's like 1 plus 1 and then you solve it. But in an expression, you won't see an equal sign. The only difference between an expression and an equation is that equal sign. So we want to answer the question, what exactly is an equation? What is an equation? And to answer that for you, the way that I like to describe it is a number sentence with an equal sign in between two equal values. So an equation is just going to be some numbers on one side, an equal sign, and some numbers on the other side. And those numbers are going to be equal to each other because that's what the equal sign tells us. So some examples might be two plus 3 equals 5. This is an equation right here because we have an equal sign in between two equal values. 5 is on one side, 2 plus 3 is on the other. 2 plus 3 equals 5. This is a true statement. So that is what an equation might look like. Now, what if I were to give you some blanks to fill in? I want you to tell me what number would I need to write to make this a true equation?
10.
10. 5 times 2 is equal to 10. Perfect. So there's another equation. What if I had 10 minus a number equals 2? What number would I put in there to make that a true equation? 8, exactly. If I take 8 away from 10, 10 minus 8, that problem here is going to have the same value as 2. 10 minus 8 equals 2. Let's do one more example. How about 20 divided by 5? What would I need to put on the other side of that equation to make it true? 4, exactly. Exactly. The value of 20 divided by 5 is 4. So 20 divided by 5 equals 4. Perfect. Okay, now, what if we had an equation like this? What if I had 12 plus x equals 25? First off, what do we know about this x here? Well, we know that if we were going to name it, it's 1x. Okay, so if I said that x was 1, let's see if that would be an equal true statement. 12 plus 1, is that equal to 25?
No.
It's not. It's not. So
13.
it is 13. That's right. So what we're really doing here is anytime we see an x in an equation, x is going to be a number that we do not know. It stands for a number that we don't know yet. And in this case, 12 plus what makes 25? Lewis, you just said it was 13. That's absolutely correct. X, in this case, would be 13. Now, before we go on any further, I want to know, Lewis, how exactly did you figure out that 13 was X?
Which is, if it was 12, it'd be 24, so one more, 13.
Yeah, okay, so you knew 12 plus 12.
I simplified it.
Right, you kind of simplified it. So you knew 12 plus 12 would make 24, so you just added one more, and that would have made 25. So that's absolutely one way to do it. Now, I want to introduce another way.
You got easier way?
I do. Today I'm teaching you. Okay? So, anytime that we have a number sentence, an equation like this, where we have 12 plus x equals 25, our goal, and I'm going to have you guys write this down. Our goal is to get x by itself, because eventually we want this equation to become x equals something. We're going to turn 12 plus x equals 25 into x equals 13, and I'm going to show you how we do that. Sounds scary? It's a lot easier than you think. All we need to do here to get x by itself is get rid of this 12. So if I have a positive 12 over here, what could I do to make it disappear? Do we have any ideas?
Add another positive number to it. 2 positives equals a negative, right?
2 positives equals a positive.
Okay.
So would you change it to a negative?
Okay, yeah.
You're going to be doing something around those lines. I'm going to give you a hint. We're not doing any multiplication, any division. It's going to be really simple. If I have 12 and I want to have 0, what do I need to do to 12? Take away, subtract. So I got positive 12. I'm just going to subtract 12 from this side. And because we have an equal sign here, that means that whatever happens over here has to also happen on this side as well. That is going to keep our equation equal. So like if I had...
12 from 25?
Yes, exactly.
What you talking about?
So I'll go ahead and write that over here because I can tell your gears are turning. You're kind of figuring out what we're going to do. But I want to give you kind of a visual representation. So I'm going to...
Don't tell me 25 minus 12 is 13.
It is. It is.
Man.
But let's think about like if we had a balance, you know, like a scale. I know. So our scale is equal right now. If I took 12 away from this side becomes lighter and it's uneven. So to make it even, I got to take 12 from this side too, and that's going to even it out. So whatever we do to one side, we've got to do to the other. So right here, we took 12 away from 12, so we can just cross this out. I'm not going to write 0 plus x equals something. I'm just going to get rid of it and write x now. So I'm bringing that down. Then I'm going to bring down my equal sign. And now I'm going to do 25 minus 12. What is that going to give me? 13. And guys, look at that. We came up with our answer by getting x by itself. We got x equals 13. And
easier than I did.
right. So all you got to do now is, you know, if you're unsure if you did it correctly, we could plug this back in, or we could replace x with 13 and see if it's true. So I have 12 plus 13. Is that equal 25? It sure does. It sure does. So that's absolutely correct, guys. We're going to do a couple of examples together. So, what if I had x plus 10 equals 15? Remember the goal we wrote up here. Our goal is to get x by itself So we want to get rid of anything that is keeping it from being alone. So I've got x plus 10. What should I do to get rid of that plus 10?
What we do?
Add it to 15.
So add it to 15?
Subtract it.
Yes, let's subtract it. So we want to do the same thing to both sides here.
Subtract the 10 from 15.
Minus 10 here to cancel them. And then minus 10 on the other side of that equal sign. Now I'm going to draw a line under it.
And that'll work for any, no matter how high that number
Yes.
gets.
It'll always work.
See, this way is more difficult for me.
What way do you do it?
Just 5.
Well, I know that you might know it's 5 just by looking at it.
So it's not.
It is. It is. But when we start moving to numbers, like what if I gave you a x plus 256 is 547. Do you know that in your head?
I mean, now I gotta have to do some math.
Yes. So what I'm teaching right now, what I'm teaching you is the math, so that we know what method to use when we get up to more difficult numbers. So we're starting with simple numbers just so it's like, oh, I see that. Yeah, it is 5. So our 10s cancel. Now we have 15 minus 10, and what is that? 5. And we know it's right. We're going to make sure, though, that we bring everything down. We don't want to just say 5's our answer. That doesn't tell us what x is. We need to bring our x down, our equal sign down, and our 5. And then we circle it. X equals 5. So how about just for fun we do this big one? I got x plus 256 equals 547. Remember, our goal is to get x by itself. What do I do first?
Subtract 256.
Absolutely. Subtract 256. What else do I need to do?
Put it on the other side.
Whatever I do to one side, I have to do it to the other. Okay. So then I like to draw a line to show what I'm doing. My 256's, they cancel. Now I'm going to bring down my x equals, and then on your calculators, what's 547 minus 256? 291. Good deal. And if we wanted to check to make sure that's right, we could do 291 plus 256, and our answer better be 547. It is. Awesome. So we did it right, guys. Good. Very good. Okay.
I guess what I was saying is sometimes the long explanation isn't, they tend to confuse me sometimes.
Yeah.
Versus just the shorter.
I get you. I get you. I know what you mean. So anytime I'm given kind of a longer explanation, it is more so because I feel like to really understand mathematical concepts, it's very important to also not just understand the steps we're taking, but to really get kind of the theory of it and why we do each thing. So if you get it and you can move forward, that is wonderful. But I know some people, it's just really good to be able to understand all the why behind it. Okay, does anybody still need this? Are they still writing? Okay. Here's what I'm going to have you guys do now. I'm going to set a little 5-minute timer, and I want you to apply this and see if you can do these on your own. I'm going to have you do, I'm going to give you some tricky things here and see if you can figure them out. 6 plus a number is going to make 19. Number 2, I'm going to have you do 23 is equal to 16 plus a number. 37. Okay. And I'm going to pause this recording so anybody watching can try this on their own. Okay, so for number 1, what is my first step? What do I need to do?
Minus 6.
Yeah, we want to get x by itself, so we're going to take away 6. So subtract 6 on both sides. Yes. Then we want to bring down what's left over. Those 6's cancel. We're going to drop down the x, drop down the equal sign, and what do we have left to do?
19 minus 6.
Yes, what's 19 minus 6?
13.
13. Did anybody get something different? We all got that one? Good. Okay, let's look at number 2. This one looks a little bit different. This time we have our number by itself over here, and on the other side of the equal sign I have 16 plus x. Now, just because it's ordered differently does not mean that our goal changes. We still are trying to get x by itself. What's our first step here?
16 minus 16.
Absolutely. We have a positive 16 here, so we want to subtract 16 so that they can cancel. What else do I need to do?
Bring it down.
Bring what down?
The x equals.
I missed a
Put
step though.
16 over minus 16.
Yes.
23.
Whatever we do to one side, we got to do to the other.
Minus 16 from 23.
Perfect.
Get 7. X equals
7. Perfect. Did anyone get something different?
I did.
What'd you get, Dorica?
I don't know. I got 39.
Oh, girl, what'd you do?
Right.
Oh, you added, didn't you?
So we're not adding, we're subtracting.
So if we have a positive number, like 16, if I added 16 to it, I'm going to get, what is that, 32? Something like that. Then I would have 32 plus x equals 39. Then I still have a whole nother problem to do. We're trying to get rid of the 16.
So why did we do 16 instead of 23?
Ooh, that's a great question. So the reason that we subtracted 16 instead is because our goal is to get x by itself. We want to get something that says x equals a number. So if I subtracted 23, let me get a separate sheet so I can kind of show you what would happen here. If I started with 23 equals 16 plus x. If I, would you say subtract 23?
Yeah.
Let's try that. Minus 23, minus 23. My 23 minus 23 is going to give us 0
Right, negative.
equals, and then, let's see, 16 minus 23, that's negative 7.
Tell you x would be negative 7, wouldn't it?
So now I have 0 equals negative 7 plus x. I still don't have an equation that tells me x equals something. So I haven't figured out my answer here. Now, whatever you do to one side, as long as you do it to the other, you still can use this way to get the answer. If I wanted to, I could just say, okay, well, how about I just add 7 to both sides? Because I want to get rid of that negative 7. So those will cancel, and then I would get 7 equals x. You could still do it that way. It's just a lot of extra steps. Yes?
Okay, my explanation, it might, I don't know which one. It's just, how I look at it for me is, your answer is first. So you just want to, I just flipped it. I put 16 plus x equals 23.
Mm-hmm.
Okay.
And you could do that, absolutely. You could.
Okay, well, for me, I don't know, but.
Now, I love that idea. You absolutely, in a simple equation like this, you could flip it and say 16 plus x equals 23.
More difficult.
However, we do need to get used to keeping it like this for future equations where we can't flip it. So, the main thing I want you to take away from this is we're trying to get everything rearranged in a way that we come up with one number on one side, then an equal, and then x by itself. So if we have 16 plus x, we've got our x over here already. We just are trying to get rid of that 16. So if we've got positive 16, we're going to subtract it, cancel it, and we got to do the same thing to both sides. Then we do that 23 minus 16 and get 7. Does that make sense? I hope so. We'll try this next one because it's the same way. Number 3, we have 37 equals x plus 23. Now remember, our goal is to get x by itself.
We want minus 23.
Yes. So if I have x plus 23, to get rid of the 23, I need to subtract 23. And whatever I do to one side of the equation, I've got to do to the other so that my equation stays balanced. Right?
Drop down.
Yes. My 23's cancel. We'll bring down our x equals. And then what is 37 minus 23? What'd you say? 14.
Got it.
Perfect. Everybody get that one? What'd you do different on that one?
I think I keep adding because I got 60.
You added on it. Okay. Okay, so just remember, now there is going to be one where we do add, but when we have a positive number that we're trying to get rid of,
And I keep taking, I'm not taking the 23, I'm taking 37.
okay.
Not sure.
So,
Yeah.
yeah, it sounds like you're wanting to mess with the stuff on the left side. Mm-hmm.
It don't matter. A little bit, yeah. I think I just gotta stop adding because I'm adding.
Mm-hmm.
Oh, no, okay.
So anytime that we're working out an equation or a math problem, anything,
Whatever it is plus x.
we just want to make sure that everything we write down, we know why we're writing it down. We want to be super intentional about every step. So anytime we're looking at, okay, what do we do next? We want to be super intentional. So in number 3, I'll write it again and we'll look at it together again.
Sorry, kid. I've been there many times.
Right, no, I get it, and I want everybody to feel okay about this. So what we have here is 37 needs to be our total. Then we're trying to figure out what x is. We're trying to figure out what number we need to add to 23 to make it 37 as a total. So it would be like, if I could show it visually. Okay, here's 37. Here is 23, and then it's like this is my x. I'm trying to put these two together to make them equal to this 37 here. So in order to find out how much x is going to be, what we're going to do is we are going to know, or we're going to know here that this 23, we don't need it anymore. We just need to figure out what this number is going to be. If I were to pick this up and put it on top of the 37, what I'm trying to see is how much is left over here that we still need. That x is going to be whatever is left after we take the 23 away from this. I'm trying to find a better way to explain it, and I feel like I'm just making it worse.
No, we're taking 23 away from 37.
Yes.
See, for, like how my head is weird. But for me, for these simple ones, more simpler ones, 37 is your answer.
Right.
X plus 23, it's going to equal to 37. So 37 is just the answer. So you're going to subtract it because you have to total 37.
Okay.
Right.
That's just, I don't know if
So
that's.
blank
Subtract
plus
your
23
number.
equals 37.
Yeah, subtract your
Okay.
number.
Yeah. So X or any variable, all this is it's a number we don't know. It's a number that we're going to discover by doing this process. Gosh, I wish I had. I'm asking for them. They're like algebra tiles.
Subtracting our number from the answer and the equals, and that is our X.
Okay.
Yeah. Yeah.
Does that make sense?
Yeah, so since it's equal to 37, I wouldn't do 37 on both sides.
Yes.
It's 23.
Exactly. Good. Okay. Let's look at 4. We have X plus 21 equals 45. What should I do first?
21 minus 21.
Let's take away 21. And where else are we taking 21 away?
45.
Yeah, under the 45. We got to do the same thing to both sides to keep it equal. Good. We're going to bring down our X equals. Yeah, what's 45 minus 21? 24. Did everybody get that one? Okay. All right, guys. Let's go ahead and look at something else now. We have, I'm going to write up here, X minus 3 equals 2. Okay, so we need to know what number would we need to start with that when we subtract 3 from it, we're going to get an answer of 2. Do we know what that number might be just by looking at it?
1.
Is 1 minus 3 equal to 2?
Oh shit. 5.
5. Yeah.
My bad.
You're
My
good.
brain said 1, 2.
That's all right. That's all right.
I was thinking plus for a second there.
No big deal.
bad.
So I know, just because this is a simple problem here, when I do 5 minus 3, I get 2. So I know that X equals 5. Because if I replace that X with the number 5, this would be a true statement here. 5 minus 3 is 2. So what I want to see here is, how did I get my equation to go from X minus 3 equals 2? How did I get it to this? How did I go from here to there? And I'll show you real quick before we try on our own.
I did the same thing you did the first time.
That's all right.
Mentally.
So remember, our goal, it never changes. We're trying to get X by itself. We're trying to isolate that variable. So in order to do that, I need to get rid of this minus 3. We can also think of it as a negative 3. What would I do to get rid of a minus 3 or a negative 3?
Plus it by our answer.
We're going to do the opposite. We're going to add this time. And remember, whatever we do,
2. You got
No.
2.
we're trying to get rid of this.
Yeah.
We're trying to get rid of minus 3.
We're trying to get rid of it and make it a positive 3.
Negative.
We're trying to make it disappear.
Oh, yeah.
Oh, okay.
We're trying to make it disappear so that X is by itself.
Gotcha.
So, if we have minus 3, to make it cancel, we put the opposite here. We put
Okay,
plus 3.
Yeah.
And whatever we do to this side, we must do to this
That
side.
So we gotta do plus 3 down there.
So these cancel, and what do you know? 2 plus 3 is 5.
Gotcha.
Yeah, does that make sense?
Yes.
Good.
Gotcha.
Okay, let's do another one like that.
Plus 3.
Let's do X minus 10 equals 15. Okay, what would we need to do here?
Add 10.
Yes, we have x minus 10. Our goal is to get x by itself. To make this minus 10 go away, we need to do plus 10. Whatever we do to one side, we've got to do to the other. Plus 10. Okay, now that I'm here, my minus 10 and my plus 10, they cancel out. So we are going to cross them off. Then we're going to bring everything down. We've got x equals, and then what's 15 plus 10?
Jessica was able to get some caramel apples. So there's caramel apples in the student fridge if anyone wants some.
Okay.
It's like packages of 3 and it's like the whole fridge is full.
Ooh, that sounds good. That sounds really good. Okay, well thank you.
You're welcome.
Awesome. Okay. And then I heard somebody say it, 10 and 15, you add them together, you get 25. So our answer here would be x equals 25. Now if we wanted to make sure that we did get the right answer, we can take that 25 that we found for x and put it back in this original equation. So 25 minus 10, is that equal to 15? It sure is. So we know we did it right, guys. We know we did it right. Okay.
Sneaky tricks.
Yeah,
But they
pretty
work.
sneaky.
They work.
How about we try the flip-flop thing again?
Good.
We've got 17 is our answer, equals x minus 20. Remember, our goal is to get x by itself. Our x is already on this side. So what are we trying to get rid of?
The 20.
Yes, we've got minus 20 here. So if we have minus 20, what do we need to do to cancel it out?
Make it a positive or add it.
Yes, we're going to do plus 20. And I got to do that to both sides. Okay, so my minus 20 and my plus 20, they cancel out. So I'm going to cross them off. Then I'm going to bring my things down. I've got x, I've got equals. What is 17 plus 20? 37. Good, 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 good. Okay. And same thing, if we plugged 37 back into this equation, if I put 37 in for x,
20.
37 minus 20, you bet it, it is 17. Exactly. Exactly. Okay, we're going to do one more together like that, and then I'm going to have you guys try on your own again. Let's do 12 equals x minus 21. What's my goal?
Get rid of 21.
I want to get rid of 21. I need x to be alone. So how do I get rid of minus 21? Add 21 plus 21. Both sides. Okay, now what?
Cross out the 21.
My 21's canceled. They're gone. Now I've got x equals
33.
33. Good job, guys. That's not so bad once you get the hang of it. It's not so bad. Okay, now,
I will say out of those, I was tricked up a little bit at first on those, but
Yeah.
I think the addition ones,
mhm.
moving to the minus one, were probably the harder of the ones
Yeah, you know, I think
at first.
this is a kind of a brand new thing, and
Yeah.
anytime we do something totally brand new, it's going to feel uncomfortable at first. But, you know, the more we practice, it's going to be easier every time. So I'm going to give
Something I
you,
won't forget.
yep, exactly. I'm going to give you 4 more practice problems to try on your own. Now, really pay attention to what exactly the equation says. Remember, if you're trying to get rid of a minus, you're going to do the opposite and add. If you're trying to get rid of a plus or a positive, you're going to do the opposite and subtract. So here's question 1, here's 2, here's 3, and 4. All right. Set a little 5-minute timer, and I want you to try these on your own.
So you said if we're adding, like,
Let's go ahead and look at these problems. So number 1, we have x minus 5 equals 13. What did you guys do first?
Added 5.
Added 5.
And then crossed that out and moved it over to 13 plus 5.
Perfect. Now what?
Drop my x down. X equals 18.
18. Good. X equals 18. Did anyone get something different? Awesome. Let's look at number 2. We have 21 is equal to x minus 4. What do we do first?
we add 4.
Yes, we do. We add 4. And we do it to the other side as well. Okay.
4 to cross out.
Yes.
And then 21 plus 4.
Mm-hmm.
And so we bring down, do we bring it down now?
We sure can.
Okay, so we equals, x
X equals
equals 25.
25, or 25 equals x. Perfect. Guys, did anybody get something different? Good. Good job. Okay, now I brought back some of our addition problems. We have x plus 11 equals 26. What do I need to do here?
Subtract 11.
Yes, subtract 11. You guys are getting it. I love it. Okay. What do we do now?
Move it over to 26 minus 11.
Perfect. What happens to my 11s?
Cross out.
Yeah, they're going to cancel out. So I'm going to have x equals, what is 26 minus 11? 15.
Got it.
Did you get that? Did everybody get that? Good. Gosh, guys, good job. Okay, last one. 31 equals x plus 15. What do we do here?
Subtract 15.
Subtract 15. Perfect. Both sides. What happens to my 15s? They sure do. They cancel out. We'll bring down our x because it's by itself now. Equals, what is 31 minus 15?
16.
16. Did everybody get that one also? Good. Good job, guys. That is wonderful. Okay. So, what we did here is we knew that anytime we have a number next to x, we got to get rid of it by doing the opposite. So if we had a minus, we would do a plus. If we had a plus, we would do minus. But what if, guys, what if we had something like this? I know, this is the last curveball I'll throw you. What if we had What if we had 5x equals 20? First of all, when we have 5x, what operation is happening here? Do we know?
5 times 5.
Ooh, so 5 times something.
5 times the number itself.
Yes, okay. So we know we're doing multiplication here, right?
Yeah.
We are. I'm going to tell you right now, it isn't 5, because 5 times 5 is 25.
4 times 5.
Yes.
My bad.
Yes. So we know that 5 times 4 is 20. So we are going to get an answer of x equals 4, because 5 times 4 is 20. But let's talk about the process to getting there. Let's talk about that. Okay? So whenever we had addition and subtraction, we would just do the opposite. The opposite of addition is subtraction. The opposite of subtraction is addition. We have multiplication here. Does anybody know what the opposite of multiplication is?
Division.
Division is our opposite. So to get rid of this, I know. So to get rid of 5 here, since we are multiplying, we're going to divide like this. 5 divided by 5 Then we got to do the same thing to both sides.
So 5 divided by 20.
Yeah, or 20 divided by 5, actually. So whenever we divide a number by itself, the answer is 1. So we would end up with 1x, which we know is the same thing as x.
Yeah.
So those cancel, and we're left with x. And then what is 20 divided by 5? It's 4. It's 4. That's all we did, guys. We're just doing the opposite every single time. We're doing the opposite. Let me give you another one. What if I had, how about 3x equals 27? I've got 3 times x. What do I need to do to get x by itself?
So when you add 3 to, divide 3?
Yes, you're going to do the opposite. It's multiplication here, so we're going to do division. 3 divided by 3, 27 divided by 3. The 3's are going to cancel. Now I've got x equals, what is 27 divided by 3? 9. And if I did 3 times 9, I would get 27. So that's perfect. Forgot to circle my answers. I want us to get in the habit of circling.
And crossing out.
Yes, crossing out and circling. Those are good things to do. Good habits to keep. Good. Okay, so we did some multiplication ones. How about this? How about,
Division ones.
how about x divided by 5 equals 10? Remember, we're always doing the opposite. So if I want to get rid of divided by 5, what would I do? Multiply, exactly. So I'm going to do times 5 on both sides, times 5. My 5's are going to cancel. And then I just need to do 10 times 5. What's that? 50. So I would be left with x equals 50. And what do you know? 50 divided by 5 is equal to 10. So we did it right. We did it right. Let's do another one like that. Let's do x divided by 2 equals 12. What would I need to do here?
Times 2.
Yes, you would. The opposite of division is multiplication. So we're going to take both sides times 2. What happens with my 2's?
They cancel.
They sure cancel. Now what am I going to do?
12 times 2.
12 times 2, yes, is 24. So x equals 24. And same thing, if I were to replace x with that 24, 24 divided by 2 is 12. So we did it right, guys. We did it right. Okay, last thing that I want you to put in your notes today, last thing is this idea that we learned today and didn't even know it. We learned about something called inverse operations. Everybody say inverse operations.
Operation.
Very good. Operations are just multiplication, division, addition, subtraction, anything that we can do with numbers. And inverse means the opposite. So what we do when we're trying to solve an equation, we always do the opposite to get rid of things. So, for example, addition, what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. Good. Oops, I didn't write that on the right line, but y'all get the idea. So whenever we are doing an equation where we need to solve for x, what we need to do every time in order to get x by itself and solve it is those inverse operations. Every time. If we're doing addition, we're going to get rid of it with subtraction. Division, get rid of with multiplication. It's always the opposite. So guys, that is the lesson today. That's everything we've learned. Here is your exit ticket. Uh-oh. I know it. I know it.